Hello fourth year, welcome to part 1 of this lesson. Today we are going to be looking at oxidation and reduction, introducing the terms, introducing the types of reactions, and then we will move on in the next lesson to combining the two and talking about redox. Today our learning intentions are for you to define the terms oxidation and reduction. At the end of the lesson, I would hope that you will be able to identify oxidation and reduction reactions from ion-electron equations and be able to write ion-electron equations for oxidation and reduction reactions. So first of all, let's explain what these terms mean. So oxidation is a loss of electrons by a reactant in any reaction. So any type of chemical reaction, if a reactant loses electrons, we can call it oxidation. Reduction, on the other hand, is the gain of electrons by a reactant in any type of reaction. So if during a reactant gains electrons, we would say a reduction reaction has occurred. In a redox reaction, which we will learn a bit more about later, reduction and oxidation go on together. You have both in the same reaction. In order to represent reduction and oxidation, we write ion-electron equations. Now the terms oxidation and reduction can be applied to more complex ion-electron equations, such as the sulfate ion and the sulfite ion, but we won't worry about that just now. Let's dial it right back. So, oxidation is the loss of electrons, and reduction is the gain of electrons. Now here is how I like to remember oxidation and reduction. I like to think of it as oil rig. So oil rig to me is oxidation is loss of electrons and reduction is gain of electrons. So if you're ever in a muddle, which one is oxidation, which one is reduction, just remember oil rig. Okay, let's go back to that last slide. So oxidation is the loss of electrons, reduction is a gain of electrons. We're on board so far. Now, we can represent oxidation reactions and reduction reactions by writing ion-electron equations. And these equations show electrons being lost or being gained. In this reaction here, we have, the zinc atom becoming a zinc 2 plus ion, and to become the zinc 2 plus ion it has lost 2 electrons. So oxidation is loss of electrons. This would be an oxidation reaction. In this reaction, our copper 2 ions are gaining electrons and becoming a copper atom. Gain of electrons is reduction. Oxidation reactions have electrons on the right hand side of the arrow, and reduction reactions have electrons on the left hand side of the arrow. Okay, so let's talk some more about ion-electron equations. The data booklet gives you ion-electron equations for a series of reductions. You have them, they're accessible to you, you'll have them in assessments and exams. To write an oxidation reaction, you need to reverse the equation. So you're given reductions. If you want to write the oxidation reaction, you have to flip it around. Let me explain. So the reduction of nickel is when nickel ions gain electrons to become nickel atoms. So the ion-electron equation for this can just be lifted straight from the data booklet, and it shows Ni2 plus ions gaining electrons to become the nickel atom. Now, if you were asked to write the ion-electron equation for the oxidation of nickel, this would involve your nickel atom losing electrons to form nickel ions. And all you have to do is take this equation from the data booklet and simply reverse it. And to reverse it, flip it round, nickel goes to Ni2 plus 2 electrons. With me so far? Let's keep going. So, when you come up against a question that is about oxidation reduction, you have to make sure you read the question carefully and write the equation with the atoms and ions on the correct side. For example, what is the ion-electron equation for silver atoms becoming silver ions? So our silver atom is our reactant. That's what we are starting with. So that's going to be on the left-hand side of our equation. And our ions are going to be on the right-hand side of the equation. That is what we're producing. So we would find the silver ion-electron equation we're given in the data booklet. And that is Ag plus an electron becomes a silver atom. So for the ion-electron equation that this question wants us to write, we actually need to reverse this. We want to show the silver atom become a silver ion. This is the reduction. We want to show the oxidation. So we need to reverse it around. Ag plus an electron. Okay, so in your pupil book on page 7, we have a series of ion-electron equations and you are asked to identify whether or not it is oxidation or reduction. What I would like you to do right now is pause the video, and if you haven't already completed it, go to page 7 and identify each of these equations as oxidation or reduction. So pause me here, come back, and we will crack on with going through these. Okay, so first up we have copper 2 ions becoming copper atoms. Let's think here. So up at the top I'm going to just write down oil rig to remind us. So oxidation is the loss of electrons and reduction is the gain of electrons. In this case, for copper ions, they are gaining electrons to become copper atoms. That is a reduction. Bromine, plus 2 electrons becoming bromide ions. That is again a reduction. For C, we have aluminium atoms becoming aluminium ions. That would be an oxidation. Aluminium atoms lose electrons to form the ion. In this example, iron 2 ions become iron 3 ions. In order to do so, they need to lose another electron, so that would be oxidation. The copper 2 plus the copper 2 plus ion becoming copper plus requires the gaining of an electron, so that would be reduction. For F, we are seeing again electrons on the left hand side of our arrow, so that would be reduction. And in our last example, we are seeing electrons on the right hand side of our equation, so that would be an oxidation reaction. Make sure in your pupil book you have all the correct answers written down beside these equations. Also on question 7, you are asked to write the ion-electron equations for 4 reactions. Again, pause me here, go into those ion-electron equations, come back and we will have a look at the answers. So first up we have the reduction of silver 1 ions, and again what I'm going to write up here is I'm going to write oil rig to remind us that oxidation is the loss of electrons and reduction is the gain. So what we are looking at here is the silver ion gaining electrons, and in doing so it is going to form the silver atom. So we should have Ag plus an electron gives silver atoms. B asks us for the oxidation of gold atoms. So let's go back up here to oil rig. Oxidation is loss. So our gold atoms are going to lose electrons to form gold ions, as shown here. In our third question, we are asked for the reduction of potassium ions. Again, reduction is the gain of electrons, so our potassium ions are going to gain electrons to become potassium atoms. And lastly, we have the oxidation of iodide ions. Iodide ions are going to be losing electrons to form iodine atoms, or diatomic iodine, and that is us done. If you're ever asked to write a reduction reaction, you simply copy the correct equation as written in the data booklet. So you have this in your data booklet. When you're asked to write a reduction reaction, you write it exactly as it is in the book. For example, the reduction of aluminium ions. You find aluminium and you write it out from left to right, as shown here. Now, if you are asked to write an oxidation reaction, then you swap the sides of the arrow around. So instead of writing from left to right, you go from right to left. You write aluminium gives aluminium 3 plus 3 electrons. So that is us done this first part of our oxidation and reduction and redox lesson. What I would like you to do is make sure that you have completed pages 6 and 7 of your pupil book, ready for the next session. And in the next session, I'm going to go on and explain redox reactions. Please get in touch if you have any questions and let me know if there is anything that you need me to go over again. Bye guys.